All right, for the Algebra 2 material, the advanced algebra concepts, which are going to cover equivalent expressions, nonlinear functions, and systems of equations that have nonlinear functions in them. For these ones, the College Board still does allow the TI-89 as well, and so the Desmos calculator isn't something that can help you a lot with a lot of the factoring and working with expressions, but the TI-89 can. So for this one, I'm going to do it by hand and show how to use the TI-89 to answer these questions. All right, so if we start with this question 36 here, the easiest way to solve this by hand is to think about how you can factor this. So you have these two groups of factors separated by the minus sign. Well, the common factor between them is that binomial x minus 2. So if we take that out as a common factor, that's going to leave us with these monomial factors of 5x and minus 9, 5x and minus 9 to form the terms of the other binomial, the remaining binomial. So if we distribute that out, we can also factor this denominator. And the common factor that you can remove from both terms in that denominator is the monomial factor 6. Taking a 6 out of 6x leaves x, and taking a 6 out of negative 12 leaves negative 2. Once you factor everything, you can then cancel any common factors, and your answer would be the resulting expression. Now, you can also use the TI-89 to answer this question, and for that, if you just type in your given expression. Now, the one thing to keep in mind here is notice right here, this is called implied multiplication. I don't have to put a multiplication symbol here. The parentheses following a number, the TI-89 understands what that's referencing. But if you put a parentheses after a variable, it doesn't understand that. So for here, in this first part, I needed to put a whole multiplication symbol for that. So if I take this whole numerator, I'm going to close this off in another set of parentheses. I can hit second left cursor to get all the way to the front here to enclose that, and then second right cursor to get back to the end of that expression, and then divide by the whole denominator, which is 6x minus 12. Notice here I don't have to factor any of this by hand. When I hit enter, it simplifies the expression for you and confirms that that is your answer. Okay. For the second problem down here, again, if you are looking to factor this by hand, what you can do is look to see between 33 and 15, there is a common factor of 3. Between the variables y to the 5th and y to the 4th, you can remove a common factor of y to the 4th. That fits this pattern that you're looking for here. Again, if we take a 3 out of 33, we're left with 11. Take 4 of these 5 y's out, leaving a y. From the negative 15, we remove a 3, leaving minus 5. We took out all 4 y's. And so this fits the pattern we're looking for. And so the only answer that we need to identify is what r represents, and it's going to be the number 3. Now, on your calculator here, you can use the factor command to find this. So under this Algebra 2, this F2 Algebra tab, the second option is factor. If you choose factor and then type the expression exactly as it appears, I can use the same variable, y to the 4th, close that off, and hit enter. It gives you this factored form, and you can see that r is going to represent the 3, and you can get your answer that way as well. Okay, the next problem here, if you're solving this by hand, we just are distributing, getting rid of our grouping symbols. So I get 6x cubed minus 2 stays as it is. Distribute the negative, minus minus becomes plus 3x cubed. Notice I'm going to vertically stack that under my other third degree term, and then minus a 7, vertically stack that under my other constant. And when I combine these, I just add them straight down. And so what I see here is that this coefficient of x cubed is going to be 9, and that would be my answer. Once again, if I'm using my TI-89, I can simply type in the exact expression that I have. Everything, just leave it exactly the same. Do make sure when you're leading, when you're starting off a number with a negative sign, use this change of sign key, not this subtraction symbol. So the -3 is the change of sign key. The subtraction symbol itself goes out front. However, x cubed plus 7, close that off. And when I hit enter here, it will combine my terms for me, and I see once again that the b value would be 9. It confirms what I have. Okay, the next problem here is one where this next problem here, you are basically being asked to expand this. Okay, and expanding means to FOIL. So if I take the product of my first and just multiply those across, so 1/3 times 5/3 gives me 1 times 5 over 3 times 3. X times x is x squared. That's my first. Go to my outer terms. 1/3 x times 1/3 gives me 1 times 1 over 3 times 3, and the x carries along. Now I move into my inner products. 5/3 times 5/3 x. I get 5 times 5 in the numerator is 25. 3 times 3 is 9 times this x. So again, notice I vertically stack this under my first degree term. And then my product of the last terms, 5/3 times 1/3 is 5 times 1 over 3 times 3. And so my question is asking me to identify b. b is the coefficient of my first degree term, so all I need to do is add straight down this middle column. 1/9 plus 25/9 is 26/9 x. And so that is my answer for that question. Now, if I was using the TID9 for this, expanding or foiling is called expanding on the TID9. So if I look in the F2 algebra tab, option 3 is expand. And so if I put this product now inside its own set of parentheses, so I am going to close off the 1/3 x plus 5/3, close the parentheses, times 5/3 x plus 1/3. Close that off, and also close off the entire expand command. And when I hit enter, it gives me that expanded form, and I see that my middle term's coefficient is 26/9, and so that once again confirms my answer. Okay. Problem 40 here, it asks you to find the product. So I am going to be multiplying these. So notice I have this monomial times a binomial, so I'm going to distribute that through. And this will also take into consideration the properties of exponents. So when I multiply exponents with the same base, I'm going to add their powers. So x times x, I add the powers, -4 plus 3 leaves a -1. Y to the 9th, there is no y's to combine with, so it just stays y to the 9th. And then my base z to the 6th times z to the -2. Again, when you take a power, or when you multiply two exponents with the same base, you add their powers. So I get z to the 6 minus 2, which is 4. Move to the next term, so plus, I get x to the -4th times there's no other x's, so I leave that x to the -4th. Y to the 9th times y to the 1st. Again, when you multiply exponents with the same base, you add their powers, so y to the 10th. And then finally z to the 6th times z to the -1. When you multiply exponents with the same base, you add their powers. So you get z to the 6 plus a -1, which would be 5. So identify which of these answer choices looks like that as your solution, and you get this final answer. Once again, I can solve this on the TID9 by expanding. Again, multiplying is expanding, writing it in the polynomial form. And so if I choose F2 algebra tab and select expand, I can once again put the product of these two expressions. So x to the power of -4, again use the change of sign key, times y to the power of 9 times z to the power of 6. Implied multiplication is fine right here. And this is all being multiplied by the binomial here, x cubed and z to the negative 2 plus my next term y to the first, which I can just leave y, but I'll write the power here anyway, z to the power of negative 1. And when I close this off and then secondarily close off the expand command, when I hit enter, I get my same expression that I have here. Now, do keep in mind the way that this wrote it is my negative powers were moved to the denominator. And so when I rewrite this or convert it out, I get y to the 9th, z to the 4th. This x to the first down here gets moved up and becomes x to the minus 1, plus my second fraction, y to the 10th, z to the 5th, and this x to the 4th down here gets moved up, becomes x to the negative 4th. Again, when you move an exponent from the denominator to the numerator, you change the sign of its power. And so these are equivalent forms for that answer. Right. Probably the most common two nonlinear functions that you need to be able to work with are quadratic functions, probably first. And there's three forms that you'll see quadratic functions. One will be written in what's called general form, ax squared plus bx plus c, where everything's expanded out. The second form that you might see would be vertex form, a times the quantity x minus h squared plus k, and then the final form would be this intercept form, which has the form a times x minus p times x minus q. Now, we'll talk a little bit more about these different forms later, but here, when you're looking for a vertex, and minimum or maximum are two keywords that tell you that you're looking for a vertex. There's several different ways, or each of these has a specific way that you can find the vertex if you're given this form. So for the general form, the x-coordinate of your vertex is negative b over 2a, and then if you take whatever that quantity is, negative b over 2a, and you plug it back into the function and evaluate it, that would be your y-coordinate. So we can see that right here in the notes. And for the vertex form, it's just the point hk. And then for the intercept form, it's the average of the two x-coordinates, so p plus q divided by 2. And then just like what we did in the first, if we take whatever that quantity, whatever that x-coordinate is, and we plug it back into our original function and evaluate, that would be its corresponding y-coordinate. So for this problem, the easiest thing to do right here is probably just to manually use the negative b over 2a pattern to find, again, minimums and maximums are both a vertex, depending on whether the graph opens up or down. And so my b value is my coefficient of x, so I plug in a negative 34 over 2 times my a value is the second degree terms coefficient, which is 7. My negative signs cancel, 2 goes into 34 17 times, and so I get my answer of 17 over 7. And so that would probably be the quickest way to answer this question. Now, you can also answer this question by using Desmos here, and if you use Desmos, what you could do is you could just type your equation directly in to the calculator. And if you click on the vertex, you see that your answer is 2.429. Okay, again, the college or the SAT will accept decimal answer, so it should accept this as a correct answer. However, that is an approximation. Okay, if you needed to or wanted to confirm that this is the fraction form, or what the fraction form is, what you could also do is you can use the process like we did with linear regression, but use quadratic regression. And so with that in mind here, this vertex form is probably going to, or it's going to give you the information about the vertex the easiest. And so what you could do to use linear or quadratic regression is you always need to pick one more point than the power or degree of your expression. So if you're using linear regression to x to the power of 1, you need 2 points. If you're doing a quadratic regression where x is to the power of 2, you need 3 points in your table. So if I create a table here and I evaluate, or if I use the 3 of the points on this function that I can see, well, the points that I can choose are, again, and they can be any points, so probably the easiest thing to do, because I have a function already written up here, is just choose an x-coordinate and then enter the answer from function notation. So whatever f of 0 is, you can then choose 2 more, 1 and f of 1, 2 and f of 2. Again, this is probably the easiest way to go about solving that. And then what you can enter here is your regression equation, and the regression equation is just this function right here. This, I'm going to use vertex form, so my hk value tells me my coordinates of the vertex. And so you will use y1, y sub 1, the 1 will automatically go subscript. Use the similar to button in the keyboard under the letters, it's this key right here. And then just type what you have. So our coefficient a times the quantity x minus h, again I'm using my keyboard here, squared, and then plus k. We do need to make sure our x's are, the x's and y's all have the subscript, so notice the difference here. Once I change this x to x1, it now gives me my values for h and k, and it confirms that 2.429 is my h value, but if I want the fraction form, I can just type h in an open cell, hit this fraction, convert to fraction key, and then see that it is in fact 17/7 is the fraction form. So again, as you can see, it was much easier to do it by hand. That's the way I would recommend, but you can use a calculator, the Desmos calculator, for that as well. Right. The other type of question you're going to see with these nonlinear or quadratic functions especially is questions that involve the discriminant. Now, the discriminant, the combination of these two, the vertex and the discriminant, are found in using quadratic formula. So if you took this general form, quadratic formula allows you to solve for x, right? It's negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. So that's how you can solve for the x-intercepts, or the solutions of quadratic equations. Here is the x-coordinate of your vertex. Okay, and this part in here is called the discriminant. And the discriminant has 3 rules that determine how many solutions your function has. If this number that's inside the square root is 0, that means that this whole second part will cancel out and you are only going to have one single solution. And if it's a positive number, then you're going to have 2 solutions, the x-coordinate of the vertex plus that quantity, whole quantity calculated, and the x-coordinate of the vertex minus that quantity. And then finally, if it's a negative number, you can never take the square root of a negative number. So if the discriminant is negative, that means that the equation will have no solutions. Okay, that means the graph will never cross the x-axis. So here, for a problem like this one right here, it's telling you that the parabola intersects the x-axis at 2 points. Okay, what that means is that the discriminant is going to be positive. So this means that this means that b squared minus 4ac is going to be greater than 0. Okay, so in order to check to see which of these values will work. Okay, what you would need to do is the following. We first need to find an equation of this graph in general form. So we have the vertex. This is the h value and the k value. So what I can do over here to the side is I can say y is equal to a times x minus our h value of 9 squared plus our k value of minus 15. So notice I don't know what my a value is here, but I do know my other expressions. So if I expand this out in the way that it is right here, so if I expand this binomial square, I get x squared minus twice the product of these terms, so x times a negative 9 doubled is negative 18x, plus this last term squared, so negative 9 squared is plus 81, minus this 15. And so again, I'm going to distribute to get rid of my grouping symbols. I distribute this a, I get a x squared minus 18 times a x plus 81 a minus 15. So notice here the way that this is set up is here is my a value, here is my b value, and here is my c value. Right, so if I take all of this right now, this a, b, and c value, and I plug those in here, so I have b, which is negative 18a squared, minus 4 times my a value, which is a, times my c value, which is this whole expression, 81a minus 15. And so that whole thing is greater than 0. So what I can do right here is I can sort of simplify what I'm working with. So I will use a calculator for this. If I take negative 18 squared, I get 324. So this is a positive 324. A gets squared as well. Next, I'm going to take 4a and I'm going to distribute that here. So if I take 4 times 81, I get also minus 324. A times a is a squared. And then 4a times a negative 15 becomes plus 60a. And that's all greater than 0. So here my a squareds cancel and I get 60a is greater than 0. If I divide both sides, I get a has to be greater than 0. Okay, so I know that my a value needs to be a positive number. Right? And so what I can do with this is, again, here's my a value, here's my b value, negative 18a, and here's my c value, 81a minus 15. So if I take this whole thing, I know that this quantity needs to have an a value that is positive. And what could this be? I'm going to test my different values here. So if I look at the sum of these, a minus 18a plus 81a minus 15, combine my like terms. So 81 minus 18 is 64a. So if I combine all of these, a minus 18a is negative 17a, plus 81a gives me a net of positive 64a minus 15. And so what I want to see is if this is the sum here, so a plus b plus c. So if I'm thinking this number right here has to be one of these answer choices. So if I add 15 to this, I'm left with 64a is equal to whatever the sum is plus 15, and then divide by 64. And so I know that when I do this, my a value has to be a positive number. Okay? So the only way that this will work is if the number I choose plus 15 when I divide by 64 gives me a positive number. So if I just test each of these scenarios, from the answer choices. Oops. Okay, so if I use a negative 24 plus 15 over over 64, that gives me a negative number, so it's not that. If I use negative 15, oops. So if I use a negative 15 here, I get 0 over 64, which would be 0. It's not that. If I use negative 18, I get a negative 3, so that would become a negative. And so the only one that works is this last one. If I used a negative 13 plus 15 gives me a positive 2 over 64. That's going to give me a negative number. And so my only possible solution would be the negative 13. So again, the general form for a quadratic function is ax squared plus bx plus c, and the vertex for this we just saw was negative b over 2a, and then evaluate the function for that value, and that would be your corresponding y. For the other forms here, so this is general form, we have vertex form, and we have intercept form, and their corresponding vertices. Okay, so for this first problem here, the easiest way to answer this is to just understand how vertex form is set up. And so they gave us vertex form, the value of x that gives you, or when you read this question, it's asking you to find what is the vertex telling you, or what information is that. And so here the vertex has an x-coordinate of the value of x. It gives you a 0 inside the parentheses, which is 3. And then outside the parentheses, that's the y-coordinate of your vertex. So this is what our vertex is. And so the vertex tells you that, again, the x is the number of seconds. So after 3 seconds, and y is the height, this will be 7 inches high. And so when you look to see what is it that this is telling you, the metal ball's height was 3. Nope, it's not talking about the height, it's talking about the time. The metal ball's minimum height occurred 3 seconds after it. Yes, that is what the x-coordinate of your vertex is telling you. So this question is asking you to find the second intercept, x-intercept, when you know a vertex and you know one of the given intercepts. So if the vertex of this graph is the point -6, -4, and one of the x-intercepts is going to be -41/4, 0, and you want to find the other intercept, it's also going to have that x, or the y-coordinate of 0. One of the things to keep in mind regarding the graphs of all parabolas is that the graph is symmetric through the vertical line passing through the vertex. So if you know that the vertex is at the point -6, -4, so let's say that's right here, okay, and you know that you have an intercept, an x-intercept at -41/4. So that's -10.25. So that's over here to the left. So this is what your graph looks like, and that is -41/4, 0. And so what that means is that if you had a vertical line passing right through that vertex, this graph is going to mirror across, and that means that the distance from this graph to that vertical line, or this intercept to that vertical line and this intercept to the vertical line, are exactly the same. So if you took the difference between these two values right here, so if I took, again, the way that you find the difference would be absolute value of their difference, so -41/4 minus a -6. If I took the absolute value of that, that's going to be my distance. So absolute value of -41/4 minus a -6. So notice that that distance is 4.25. So what I can do is if I subtract 4.25 to go this direction, I can add 4.25 to find what this next intercept would be. So if I were to take a -6 and add that distance 4.25, my next intercept would be -1.75, and so that's the number that's going to go here. Now, if I want to find the fraction form of this, -7/4, I just click the fraction bar to format the answer as a fraction, and that would be my solution. So if I wanted to solve this problem by hand, what I could do is I could manually test each of these points to see which ones give me true statements, but because I'm allowed to use, or because Desmos is built into this test, what I would recommend is just use the quadratic regression. And that means if we create a table of these values that we were given, so add the plus symbol, choose table, -1, 4 is my first set of points, 0, 13 my second set of points, and 1, 24 is my third. Because I'm finding a quadratic function, I need 3 sets of points, so I do need to enter all 3 of those pairs. And once I do that, I can call up the quadratic regression, which is y1 is similar to, and then my answers are all in general form. So the form that I'm going to choose to write here is my general form, which is a x1 squared plus b x1 plus c. Once I do that, I see what my coefficients need to be. My coefficients are 1, 10, and 13. So here's 1, 10, 13. And so the first answer choice is my solution. Again, make sure when you are typing your functions, if you leave out the subscript in either of these x's, you see it won't give you the regression, so you need to make sure you call on y1 and then x1 when you are entering those. Okay, this last question here, again, is just understanding what the factors of the quadratic function give you. The factors are the x-intercepts. And so if you set each of these factors equal to 0, those are your 2 x-intercepts. So when you answer this question, you can either choose the value of x that gives you a 0 here, -4, or the value of x that gives you a 0 here, which is 6. And either of those would be your correct answer. Now, if you type this function directly into Desmos, which you shouldn't need, but if you did, if you weren't quite sure or didn't remember, you could type those functions in, and then you can simply click -4 and +6. It confirms that we have the correct values for those x-intercepts. Right, the other main type of nonlinear function that you need to be very familiar with is exponential functions. So exponential functions have this form right here, where this is either a growth factor or a decay factor, depending on whether it's greater than 1. If it's greater than 1, then you're looking at a growth factor. If it's less than 1, if it's a negative number, or not negative number, but a value less than 1, then you're looking at a decay factor in there. And so it's just, for the most part, you need to know what you're interpreting. So here, if you have a model that predicts an original starting point of 15,000. So that is going to be the number that goes out front. This a value here is the initial amount. So when we look at this function, we're going to take 15,000 times 1 plus or minus. When we look at this, we are looking that this is an increase, so a growth of 6%. 6 as a percent is 0.06, and then to the power of t. And so this is the interpretation, and so your answer is going to be this third option right here. And again, you don't need a calculator for this, it's just an interpretation. For the next example here, it's the same idea. You're looking at, when you scan your answer choices, you see that you're dealing with exponential function. And so when we are evaluating this, we take our original amount here when q is 0, so when the time is 0, q is equal to 21, so that means that is your starting amount. And then you take 1, now it's a decrease, so we're subtracting 34%. Our decrease of 34% is minus 0.34 for every increase in x. And so our power is x, or every increase of x by 1. And so here is our exponential model with this decay. And if we take 1 minus 0.34, we get 0.66. And we see, once again, our answer choice is this third option. And one of the other things that you need to be familiar with is when you have this t value, the time that it takes for this growth or decay to happen. If you have a fraction written there, then that means that every time period that happens, that fraction of it occurs. So if this was a 1/2, it means that for every t, so this is a 1/2 t or a t over 2, it means that each increment of t, half of that growth happens, and so it's going to take 2 units, 2 values of t before the 1 growth factor or decay factor occurs. If this was t over 6, that means that it's going to be 6 of those time units before the 1 growth or decay factor occurs. And so you really do want to key in, if you see a fraction in the power of your exponential function, that is the number of increments of the time that need to occur for the growth or decay to occur or to happen. So here, if this is asking you how much time does it take for the bacteria to double, well, doubling is the growth factor, and it means that every increment of t, 1/670th of that doubling occurs, and so it takes a total of 670 of those minutes or time units to occur before 1 doubling happens. And so that would be the number of the minutes to double. Okay, so again, if we look at this second example here, if you're looking at this, it asks us if a certain piece of equipment decreases in value every m months. So notice this one is asking us for months, and then it asks how much does the value decrease each year? Well, each year is 12 months. So this is going to occur one time during the 12th month period, and so that decrease of 0.64, which again represents 64%, means that you got that by removing 36%. So there is a decay factor of 36%, so that means that each year or every 12 months, that's going to occur. So again, that power, or that denominator of 12 indicates how many how many time units it takes for that one decay factor of 36% to happen, and so each year it will decay by 36%. Some of the other types of nonlinear function problems that you need to be able to do are to recognize the properties of graphs. And so when you are looking at these functions, what you should see is that if you have a positive leading coefficient, so beside quadratic functions and exponential functions, other nonlinear functions that you need to be familiar with are mostly just the rules of polynomial functions. So here, when you're looking at this problem 51, it's based on the idea of end behavior. So when you look at this here, end behavior of a polynomial graph, if you have a positive leading coefficient, then your odd degree polynomial is going to go up and to the left. You don't know what happens in the middle, but it's going to go down and to the right. So for non-quadratic functions and or for nonlinear functions that are not quadratic functions or exponential functions, really what you need to be familiar with is the end behavior. So for any odd degree polynomial function with a positive leading coefficient, the general rule for that would be if it's an odd degree and a positive leading coefficient, the graph is going to go down to the left, up and to the right. If the leading coefficient is a negative number, however, and it's an odd degree, then that gets flipped. It goes up and to the left and then down to the right. For functions, any polynomial functions that are even degrees, if it has a positive leading coefficient, then you're looking at a graph that goes up to the left and up to the right. And if it's a negative leading coefficient and an even degree polynomial function, it's going to go down in both, to the left and to the right. So those are your general behaviors. The other thing that you need to pay careful attention to, or that you're responsible for knowing, is this concept of multiplicities of factors or zeros. So anytime your graph crosses the x-axis, it has several patterns that you need to be familiar with. If it crosses and goes straight through, like what you see right here, then this is a multiplicity of 1. That means that this factor that corresponds to the 0, x minus a negative 4, is going to have a power or a multiplicity of 1. If your graph bounces off the x-axis like this one does, then what you're going to see is it takes this factor of x minus a negative 2, and bouncing off has a multiplicity of 2. So that factor will be squared. And then finally, if it snakes through, like this one is snaking through up and to the right, if you take this factor, which is an x minus 2, its multiplicity will be 3. So a review, if you have a graph that passes straight through, has a multiplicity of 1. If it bounces off the x-axis, a multiplicity of 2. And if it snakes through the x-axis, has a multiplicity of 3. So based on those kind of properties of end behavior and multiplicities, when you look at this graph here in problem 51, it opens down in both, so that means that it's an even degree with a negative leading coefficient. Okay, and then you see from the intersects, it passes through at x minus a negative 3, so x plus 3 is just straight passes through, so a multiplicity of 1. It bounces off the x, plus or minus 0, so bounce is a multiplicity of 2. And here it passes straight through this factor x minus 7, so also a multiplicity of 1. So when you're looking at these, what you see is all of these are negative signs. Here you have an x plus 3 to the first, an x minus 7 to the first, and an x squared. So the only one that fits all of those conditions is this second option. In addition to these properties, the other thing that you would be expected to be able to do with a nonlinear function is to isolate different parts of that equation. So here, if you look at all the answer choices, you can tell that it is basically just asking you to isolate this portion of the function. And so if you just treat that whole portion as one unit, if we cross multiply or multiply both sides here, we get p times 7j plus 3 is equal to 1 times k. And then to isolate the 7j plus 3 here, you simply undo and divide both sides by p, and that gives you your expression completely alone. And so your answer is going to be this third option, k over p. All right, finding solutions to these quadratic functions or nonlinear functions is something that you can do either manually or with the Desmos calculator or the TI-89. So let's look at each of the instances. Okay, so for first, if you're solving this by hand and you want to find a solution, you can just factor and set your factors equal to 0. If you can do that, then solving it manually is pretty easy. So are there two factors of 80 whose sum is this middle term's coefficient negative 18? And the answer is yes. This factors into x minus 10 and x minus 8. And if you set each of those factors equal to 0, you get your two possible solutions. So either 10 or 8 would be your answer to that. Easiest thing, again, pretty easy to solve by hand. If you do want to use a calculator, even though you can solve this on Desmos, if you are typing this equation in directly on Desmos and you set it equal to x, you can click and see 8 and 10 would be your two solutions. Okay, you can also solve this on the TI-89 by using the solve feature under this F2 algebra tab. And so if you just type the equation as it appears, x squared minus 18x plus 80 is equal to 0. The formatting is you would use comma to designate to the calculator what you want it to solve for. You want it to solve for the x, so follow that with an x, close the parentheses, and when you hit enter, it'll give you your two solutions. So those are the different ways that you can do it. Depending on whether or not they will still allow the TI-89, which as of for this first set they are allowing that. Okay, we look at the next example. Again, when you're working through the next example, there are trying to factor this, there's no factors of negative 6 whose sum is a negative 8. So this is one that you have to solve if you're going to do it by hand by either using quadratic formula, which we see up here, okay, or by using completing the square, which completing the square is probably the preferred method if you are going to do this by hand. If you are going to complete the square, what you would do is you would move your constant over to the other side. So we would add 6 to both sides, and then you can complete the square. Take half of your first degree term's coefficient. So half of negative 8 is negative 4. If we square that and add it to both sides of the equation, negative 4 squared is 16. So that allows us to balance the equation. And we can rewrite our left side now as a binomial square, and the terms of that binomial are x, and then this number that we took, half of our first degree term's coefficient, including its sign. So x minus 4 quantity squared is equal to 22. Extract your root. You get x minus 4 is equal to, when you extract the root, you have to take into consideration both the positive and negative root. And now when we add 4 to both sides, what we see is the form that we're looking for. It tells us 4 plus the square root of some number. So our answer for this is k value, which is the number in the radical, 22. Now, not everyone is as comfortable working with these completing the square. So if you saw this and if you looked first to see can you factor it and you saw no, then it's likely going to be something where if you try to solve this on the Desmos calculator, it may not be the most efficient. You can find decimal values, okay, but neither of these decimal values give you the form that you're looking for. Now, you can kind of manipulate them and find it, but that's not even worth the time because if you have a TI-89 and can use that as well, what you can do in a TI-89 is just go into, again, use that solve feature. So F2 algebra tab, solve, type the equation exactly as you have it, and it will solve irrational solutions for you as well. So when we set this equal to 0, comma x to tell the calculator what we want it to solve for, and hit enter, notice it gives us our answer for a positive 4 plus or minus root 22, and so you can see right here, verify that 22 is your answer for that. This last question here can kind of be a tricky question because a lot of times what students would see on something like this is they would just divide both sides by x minus 2 and say that x minus a equals 0, solve for x, and you would get x is equal to a. Well, if you do that, you can even see none of those answer choices say 1 only, so you're missing something if you use that as your solution. So the appropriate way to solve this by hand is just move everything to one side, and let's keep this whole x minus 23, since we see it show up twice, let's keep it as a binomial when we move it over. So if we subtract the binomial x minus 23 from both sides, the right side stays x minus a times x minus 23, but we are subtracting this whole binomial x minus 23 from both sides. By doing this, what you can now do is treat the right side as a set of factors with a common binomial factor of x minus 23. And if you take that out, it will leave you with this whole quantity x minus a and this minus 1. It's an unwritten minus 1 here. And those become the terms of your remaining factor. And now you can use the zero product rule, set each of these factors equal to 0. So x minus 23 equals 0. Meaning x equals 23, so that's one solution. And here if you say x minus a minus 1 equals 0, and we solve, and we look to answer this question, you get x is equal to add a to both sides, add 1 to both sides, and that would be your solution. So a plus 1 works. And so those would be your two answers, 2 and 3. Now, can you solve this using Desmos? Let's take a look really quickly. Again, anytime we see an extra variable, that just means that we put a slider in. So x minus 23 is equal to x minus a times x minus 23. We are going to assign a value. We'll just call it 1 for right now, and let's kind of look at this. We see these two solutions here. We see 2 and 23. So we can see as a changes, what's happening to those solutions. Well, the value of 23 stays each time, but how does this relate? This solution 3.3 versus 2.3 as we keep moving it, 4.2 versus 5.2, what we see is if we take a and add 1 to it is what this solution winds up being. So that allows us to visually see that both of these are in fact correct solutions to that problem. Right, other type of nonlinear equations that you need to work with you see here are absolute values and radical square roots or radicals. And so using the Desmos or the solve feature is probably like the easiest, solve feature of the TI-89 are the easiest things to do. If you wanted to solve by hand, you could. Notice here we have two quantities with the same value, absolute value of x minus, or 4 minus x, so we can just combine the numbers out front, right? So 6 plus 8 is 14 times the absolute value of 4 minus x is equal to 126. If we divided both sides by 14, we would get the absolute value of 4 minus x is equal to 126 divided by 14 is 9. And now you can solve your absolute value equation. When we split this, each side we start with exactly what's inside the absolute value. On the right, we'll set it equal to what was given. On the left, the opposite of what was given. And then we solve each of these equations separately. So if we subtract 4 from both sides and change our sign, we get x is 13. And here, if we subtract 4 from both sides and change the signs, we get x is equal to -5. So -5 and +13, it asks for the positive solution, which would be 13. Now, rather than going through that, anytime you recognize a solve problem, you can just enter your equation. So if I type A, my absolute value symbols are right here in the keyboard. And you can also use ABS, and that will be read as absolute value symbols. So 4 minus x plus 8 times, I'll show you again here. You can use the symbols themselves as well. And then set that equal to 126, and you get your two solutions. Only one of them is positive. Now, looks like one of the issues here is that you can't see where this intersects specifically. You can see if you count, here's 10, 11, 12, 13. So you could identify that it's 13, but if it's anything within a decimal, it might not be as accurate. Okay, the TID9, again, for anything where you're solving, TID9 is probably the most efficient way to do it. Just take the F2 Algebra tab, select Solve, and type your equation. Once again, the absolute value is ABS. If you just alpha lock and then type A, then B, then S. Oops, let's multiply that. So it's 6 times. So for the TID9, the easiest thing to do is just to access the F2 Algebra tab, select Solve, 6 times the absolute value. Now, on the TID9, absolute value can be solved by locking this alpha key and typing A, B, S also works for the TID9. And then in parentheses, 4 minus x. Close the parentheses, add to that 8 times the absolute value could also be found here in this math catalog. So if you hit second and 5 under number, you'll see the command for absolute value, which is ABS, 4 minus x. Close the parentheses, set that equal to 126, and then tell the calculator you want it to solve for x. And when you do, it's going to give you all your solutions. The positive of those is 13, and so the TID9 is probably the best approach for this one. The second problem has a square root, and so you could solve this equation by undoing your square root if you're solving by hand, and that would give you x minus 2 quantity squared is equal to 22 minus 11x. If you are solving it this way, you would need to expand this binomial square. So we square the first term, double the product of the terms, so x times a -2 is -2x, doubled is -4x, -2 squared is a +4. And if you continue to solve, move all your terms to one side. So if we add 11x to both sides, subtract 22 from both sides, and that's going to give you your equation x squared plus 7x minus 18 equals 0, and then we can solve by factoring. The two factors of -18 whose sum is a +7 are +9 and -2. And so here the smallest solution to this equation is going to be the lowest number, the number furthest to the left on a number line. So we have either -9 or +2. A negative number is further to the left. And so that would be your solution if you solved it by hand. But once again, you don't really need to solve by hand. You have the other calculators to use. You can use Desmos and enter your whole equation. So here's the left side of the equation is equal to the square root of 22 minus 11x. And if you solve that and zoom out, you can find your solution here. Now, once again, we kind of talked about this. Depending on whether it's an integer or a rational or a fraction form or decimal form, you can see this happens to fall right on -9, so you have your solution. But if it were partway through, you may not know exactly what that represents. But with the TI-89, you can. The solve feature, again, the solve feature for the TI-89 leads directly to the solution. So if you hit this F2 algebra tab, solve, and you type your equation exactly as it appears. So here the square root symbol is second times, you get x minus 2 quantity squared, close off the square root. Now in here, looks like I didn't close, or I didn't take my binomial 2, so okay. So the most efficient way though will be to use the TI-89. So if you access the F2 algebra tab, select solve and type your equation. Square root is second times, and because we have a binomial inside, we will need to add another set of parentheses, so x minus 2 quantity squared, and then I can close the parentheses that represent the radical, set that equal to second times our square root. Here 22 minus 11x, nothing's being done to that, so I just need the one set of parentheses. Comma x tells the calculator what I want it to solve for, and when I hit enter I get my solution. 2 and -9, the lesser of the values is the one, the smallest solution is furthest to the left, which is our -9 for this. For this last question here, you can just see from the answer, or from the answer choices, that you're solving for the variable n, and so we're just going to manipulate this equation and isolate n. So the first thing is to move the 9 over to the left side. So if you take p minus the 9 equals 17 over n. Now we'll treat the p minus 9 as a whole like binomial, and so if we cross multiply, we get n times p minus 9 equals 1 times 17, and you can divide by p minus 9, and there is your n value. You see it's this fourth option from your answer choices. If you are going to use a calculator, Desmos is not really going to help you with that, but the TI-89 can if you use this F2 algebra tab and the solve feature, and you type the equation, and we can use the letters that are there. So here we can say p equals 9 plus 17 divided by, and we can use the n. And just tell it what you want to solve for. We want to solve for n, so if we isolate that and close it off, it will give us our expression, and it's exactly what we were expecting to see. Verifies that answer. All right. One of the types of questions that is being introduced into the SAT with this digital format are these questions where they're using the discriminant to help solve questions where it gives you systems that involve nonlinear equations, and it tells you that they have either one solution or no solutions. Those are usually the two cases. It can also be two solutions, but it's usually one or no solutions. And it relies on the discriminant. So again, the discriminant is taking a quadratic equation, setting it equal to 0, and the discriminant is the portion that's inside the square root when you solve or apply the quadratic formula. So it's the b squared minus 4ac. If b squared minus 4ac, the discriminant, is equal to 0, then you're dealing with a system that has one solution. If it's less than 0, then you have a solution with you have a system with no solutions. And then if it's a number greater than 0, then there's going to be two solutions. So it's the same thing that holds true for solving a quadratic equation. And so the process for these has been pretty consistent. And so this is the approach that you would take. So here, if you see that you have two equations, so notice here's a linear equation and here's a quadratic equation. So we're dealing with a system where these intersect at exactly one point. Exactly one point tells you that this relationship is going to hold true. b squared minus 4ac is going to equal 0. So that's what we will use to solve and find the value of c in this equation. So the process for solving this first involves rewriting everything in terms of one equation. So we want to replace this y with the equivalent of y here. So if we know that 4y is equal to c, if we know that 4y is equal to c, we can solve for y by dividing both sides by 4, and that's what we're going to plug in directly here. So c over 4 is equal to negative 4x squared plus 3x. And so now we're going to put that into this form. Move everything to one side. So we have 0 is equal to negative 4x squared plus 3x minus c over 4. So here's your a value, here's your b value, and this whole thing is your c value. So it's not just the letter c, c represents that constant. And so the final step to solving this is to now set it into this equation and solve. So our b value, we take 3 squared minus 4 times our a value, which is negative 4, times our c value is this whole quantity, negative c over 4. And that's all equal to 0. And when we solve for c in this resulting equation, we have our answer. So here a negative cancels, this 4 cancels with one of those 4's. I get 3 squared, which is 9, minus 4c is equal to 0. And when I solve, I can add 4c to both sides, divide by 9, and there is my answer, 9/4. And so this is the method for solving. The calculators aren't going to help unless you use them to do some of the calculating for you. Right, let's take a look at this other problem now where it's clear it's a system, a little more clear it's a system. You have a linear equation and a quadratic equation, and you're told that they intersect at exactly one point. So once again, it's that same relationship. We know that the b squared minus 4ac is going to equal 0. And so what we can do here is we can set these equivalent to each other. Just replace the y up here with the whole expression 3x plus a is equal to 5x squared minus 27x plus 49. And then we move everything to one side. So we're going to subtract a 3x from both sides, subtract an a from both sides. So when we subtract a 3x, we get negative 30x. And when we subtract an a, we get plus 49 minus a. So this whole quantity right here is your constant, your c value. So once again, we're looking at a, b, c. And so when we take our discriminant, we get b squared minus 4ac is equal to 0, where b is negative 30. Our a value was 5, and our c value is this whole expression 49 minus a, and that's all equal to 0. And so here when we solve, negative 30 squared, is the same as 30 squared, so 900. And then if you take 4 times 5, times 49. You get minus 980 for our constants, again, when we take this negative 20, distribute it through, and then negative 20 times the negative a is plus 20a equals 0. And so if we combine these, we get negative 80 plus 20a is equal to 0. Move the 80 over. We add 80 to both sides, divide by 20, and you get your a value to be 4, and that would be the solution. So be careful, we're not solving for a here. What we want to do is we want to solve for x. So what we can now do is go back in and solve our system. Y equals 5x squared minus 27x plus 49. And we have a second equation, y equals 3x plus our a value, which we just found to be 4. And so if we zoom out and look for the intersection of these graphs, right here, we can find that this one single intersection, the x value is 3. Okay, and so that would be the answer to this question. With this question is to realize we're dealing with a quadratic equation. If we distribute this x through, we get kx squared minus 36x is equal to negative 36. And so if we move everything to one side, so we'll add that 36 to both sides. What we can now do is look at our discriminant. Because this has no real solutions occur when the discriminant is a negative number. So if I take my b squared minus 4ac, and I know that has to be a negative value, I can go into my expression. My a value is this unknown k. My b value is negative 36. My c value is positive 36. And so if I plug those in, I get negative 36 squared minus 4 times k times positive 36. And that has to be less than 0. And so if I calculate this, negative and positive 36 squared is the same result, so 1296. Distribute or multiply through the negative 4 times 36. That gives me minus 144k less than 0. So if I move everything to one side, or move the constant to the other side here, I get 1296, add 144k to both sides, and then I can solve for k, divide by 144, and that gives me my solution, 1296 divided by 144. So my answer here is 9 is less than k, which means also k has to be greater than 9. So I'm looking for an integer that is greater than 9. The smallest number that is greater than 9 is going to be 10. Now, I could have also tried solving this visually. If I take this equation and write it exactly as it appears, and I do need to give k a value here to show up, so I'll create this slider where k is 1. And what I can see here is that my graph right now has this one intersection. Actually, I see 2. So I zoomed out to see there's 2. So as I start scrolling, as I go to the left, notice that this intersection right here stays the whole time. But as I move to the right, what's going to happen is eventually it disappears. So notice, once I get past 9, that line, there is no solution. Okay? And so the integer, the smallest integer that gives me no solution is going to be this value of 10. And again, it verifies what we calculated. Okay, this second problem here, For the second problem, we're asked which of the following values of b will have more than one real solution. So more than one real solution means that the discriminant is going to be positive number, greater than 0. So here it's already written in that the form for writing your discriminant, or that you would use to solve the quadratic formula. And so if I calculate b squared minus 4ac, this time I know it has to be a positive number. So here's my a, my b, and my c values. So I get b squared minus 4 times my a value, which is 9, times my c value, which is 25. And I want to find where that's greater than 0. And so if I multiply these out, I notice that 4 times 9 times 25, those are all perfect squares. So that means I can solve this by factoring. B squared minus 900 factors into plus or minus 30. And so I get two critical points here. When I solve a quadratic inequality, what I'm going to do is find all of my zeros. So negative 30, the signs can change. Positive 30, the signs can change. And the way that I can test these is I can plug in my individual factors, so b plus 30 and b minus 30. And I can evaluate each interval for each factor and just see where is my overall product going to be positive. So if I take my first factor, b plus 30, everything to the left of negative 30 is a negative value, and any number to the right of negative 30 is going to be a positive value. I'll do the same thing with my other factor, b minus 30. Anything to the left of positive of this critical point 30 is negative. Anything to the right of it is positive. And so if I take the product of these signs, I get an overall negative times a negative is a positive. Negative times a positive is a negative. Positive times a positive is a positive as well. And so my solution set is all positive values. So I want everything on this, in this interval and in this interval. So those are where my solutions are. And again, if I'm looking at the graph for these, really what I'm looking at is everything to the left of negative 30 is positive. In between negative 30 and 30 is a negative number. Anything to the right is also positive. So I want any number that's less than negative 30 or greater than 30. So the 5 falls between them right here. 15 falls between them. 30 falls right on it. It's negative 35 that falls outside. That's the one that is located in that region that gives you a positive value. Now, this one also we could solve by typing in the original equation as a function. So I'm just going to call it f of x is equal to 9x squared plus bx plus 25. I do want to assign a value for b, so we'll give it a value. Notice that in this, when b is 1, there are no solutions. So what we want to do is we want to scroll through to see where do we get more than one solution? Where do we get a graph that intersects at 2 points? I don't even need to slide. I'm just testing 4 possibilities. When I plug in 5, I notice there's no intersections, so that one's not it. I plug in negative 35. Notice I have my 2 intersections. Those are the 2, or that is the value that gives me 2 solutions. And so I have my answer. I don't even need to go any further, although I can, just to verify that when b is 15, I have no intersections. And when b is equal to 30, I have just this one intersection right here, okay, but it's not more than 1. So negative 35 would be your only answer. The final question here on this slide has a linear and a quadratic equation for a system. When you're dealing with systems of nonlinear equations, what's likely going to happen, or for this one, which order pair is a solution, the easiest thing to do is just to type those 2 equations into your graph. So if I take x minus 30 and x plus 5, there's one equation. I'm going to draw in the other. And I want to find the intersection. Again, when I look at this, I see that there's 2 intersections, 3, 0, and 0, negative 15. And so when I look at this answer, 3, 0 is the one that is a solution.